Hello, everybody. The topic for this week is populations. Population refers to the number of individuals of a species in an ecosystem. Every species has its own population in an ecosystem. As well, you can also talk about the population of an ecosystem as a whole. But we're going to start small by just focusing on one species, the rabbits. So this lesson is called A Shape of the Rabbit Population Graph. This is a two-part lesson. The first part, which we're going to do right now, is the minds-on activity, which means I'm going to get you to think about things before I tell you, or before you read about what they really are according to the scientific community. So here is the situation. It's a hypothetical situation. So a group of 40 exploring rabbits have wandered into a large area of natural forested land with few predators. They like it here, so they decide to stay and live here. How will the population of rabbits in this area change over time? Can you draw a graph to illustrate it? We call such a graph a model of the population. Okay, so there's a chunk of land. For some reason, rabbits have not been living in this land so far, but this group of 40 rabbits has now discovered this land. So they start living in it. And then they also notice that there's not a lot of predators there. So it's a really ideal situation for these rabbits. And the task is to kind of guess how the population of these rabbits might change. Will it go up? Will it go down? Will it stay the same? And to represent that population change over time through a graph. Okay, and when we do graph it, whatever our prediction is, we call that a model. Okay, so our prediction is a model. You may have heard that word thrown around quite a lot recently during the coronavirus epidemic, as scientists are always modeling the spread of the disease. Well, we're not going to model COVID. We're going to try to model the rabbit population. So what I'm going to do is I'm going to show 4 possible models. And at the very end, I want you to state your opinion on which of those 4 is probably going to be the most accurate and explain why. So there's no right or wrong answer. You can pick any of the 4 as long as you provide a matching explanation. Excuse me. Okay. So the first model, I call it the constant population model. And I call it this because it's predicting that the population of the rabbits is going to remain fairly constant at 40 rabbits. So here you see the number 40, and the red line is my visual representation of how I think the population is going to be over time. So this axis is labeled years. So this graph is showing that as the years go on, the population stays at 40. It's probably not going to be exactly 40 the whole time. It's probably going to fluctuate up and down a little bit. So we can still call this a constant population model. Just added some fluctuations in there, but it's still showing that the number stays around 40. Okay, this graph stays pretty close to 40 the whole time. So that's option A, the constant population model. Option B is called the linear growth model. And visually, you may see why it's called the linear growth model is because the shape of the graph is a straight line. But this time the line is getting higher and higher. So we call that growth. Okay, so the population, it starts at 40 here, and it goes up and up and up. And we say that it increases at a constant rate. Okay, so every year that goes by, we get more rabbits, but we get about the same growth every year. and when you graph that, it makes a straight line. And just like last time, we could add, like maybe we'll fluctuate. Okay, so it can go up and down a bit, but in general, it follows this pattern of increasing at nearly a straight line. That's a linear growth model. That's option B. Option C is called the exponential growth model. So it's still growth, so you're still predicting that the population starts at 40, but it goes up. But this time, it doesn't go up in a straight line. This time it's going up in a curve, and this curve is getting steeper and steeper as you go. Okay, so that's the difference between the linear growth model and the exponential growth model. The population increases at an increasing rate, so the growth gets quicker. So maybe we start at 40, and after 1 year, maybe we get 10 extra rabbits, so it gets up to 50. But then in the next year, maybe instead of getting 10 extra, we get like 30 extra rabbits. And then a year after that, maybe it grows by 50 extra rabbits. So it's not the same every year. We get more growth as each year goes by. So that's called the exponential growth model. And it goes up and up and up. And when you get to a certain point, like maybe around here, you get to a certain point, the curve kind of just takes off. And the population gets higher really, really fast. And that's just a characteristic of the exponential growth model. And once again, it might not just follow one smooth curve. It may fluctuate up and down a bit. So the dashed line may be a bit more realistic with the fluctuations there, but it's still generally increasing at an increasing rate. Okay, and then option D, the last option, is called the logistic growth model. The logistic growth model is designed so that the population grows and then levels off. So we can almost split this into like two halves. So the first half of the graph for logistic growth looks similar to exponential growth. The population is increasing, and it's not a straight line really, it's more of a curve. Okay, so the population increase gets quicker and quicker and quicker. But then once you reach a certain point, instead of just taking off and increasing like crazy, this model predicts that the growth will then slow down again. Okay, the growth starts to slow down again, eventually leveling off. Okay, eventually leveling off. So that's a logistic growth model. And once again, you can add some fluctuations, so it goes up and down a bit. But in general, it follows a pattern where it grows and it starts to grow quickly, but then it starts slowing down again and eventually levels off. That's the final option, the logistic growth model. So your job is to go onto this slide, this last slide here, and you pick one of those four models of population growth, either A, B, C, or D, and then explain why you picked that one. Okay, why do you think that's going to be the most accurate model of the population for rabbits? Okay, and once you do that, click Turn In. I can see your submissions, and then you can go on to the next lesson, which you'll actually do a simulation for the population growth of rabbits using a gizmo.